recording. So we are still reviewing, and we just finished this other one here. But I want to like keep going. So like, let's do this one. And this one's harder, isn't it? Because it has this 3 foot thingy. Are y'all okay with doing this one? Let's do it. Oh man, they give me troubles too. So just pick. Always draw pictures. What I do. We start here at 6.5, and then it goes bloop like that. I don't think that there's a good formula for it. I'm just going to do whatever I normally do. But I want the X's and Y's, particularly the Y's right now. I start at 6.5, and then I'm going up more, so positive. I got the 41 sine of the 45 t, and then gravity is going to be half of 32, 16 t squared. And I'm wanting to see when this is equal to 0. So this one's the square root 2 over 2 business and whatever. I know that it looks like, oh, just go to Desmos. And I think actually we should, but knowing that it's going to be quadratic formula. Go ahead.
Actually, I was about to say using this quadratic formula.
There it is.
But then you said it, so.
Yeah, exactly. Not graphing. So to set this up easily, let me try to do this instead. Actually, what I do is just basically type the formula in there, and I'm going to change that positive to a negative here in just a few seconds. So my A is a negative 16. My B is a 41 sine of 45. Again, degree mode, it should be fine. And then my C is a 6.5. Notice that we got a negative here. So that's not right. That's basically what happened was like this, which is not what we're looking for. So I don't need the positive here. I guess I need the negative. Okay. And so then that would be time 2.0137 seconds. So note that, I mean, I got the answer very quickly without have to kind of know what to do there. This is easier. Now that we got that, I think I'm just going to go look at what they ask for, right? So they say it remains in the air for, okay, cool, 2.0137. Yeah. And then it travels, and I'm guessing that's x. So then we start at 0, 41 cosine of the 45t, and there's nothing else going on, so I guess that's it. Back to the calculator. Okay. 137. I'm just being extra careful here. There we go. Yep. 3799, which makes it into an 8. Cool. All right, not too bad then. Is this okay? I'd highly recommend Desmos Scientific, but in a very specific way. You know, we could take advantage of that today and every day. The projector looks smaller.
Yeah, it's.
That's not fun, is it? Give me a second here. Oh, Henry, were you messing with my computer yesterday? Yes. I blame Henry for any issues with this device. It was Henry's fault, okay? There's the key, like, trigger right there, right? If it's in Chinese, it's definitely from Henry. Yeah, go ahead. Yes, this guy. Oh, because it said feet somewhere. The feet. Yeah, and that's 32. If it had the meters, like the last one, it was 9.8. Yeah, like their meters.
That might be something right behind you.
Yeah, no, it is. It's something to try to remember, right? And like I messed up last time, if you remember, because this was kilometers rather than just meters, and that even threw me. Tiny little, like seriously, the whole problem you can get it wrong because of a letter, right? Nuts is what that is. But that's why we're writing it all down. You know, if you do this, I could. Oh yeah, I see that you did. You know what's going on, kind of thing. Good questions. Excellent. I think this is the same thing. Oh well, thank you for giving it to me finally. Um, finally, but it's the same one, right? 5. This guy. I don't think this matters, does it? Yeah. Oh, and they're looking for the initial speed. Oh, I think so. Yes. And so that would be only x, wouldn't it? Because this is my x right here, and then I have a cosine of this guy. I don't know if that even means anything.
We don't also don't have T as well. So
Mm,
that's fine. Both are.
let's try it. Yeah.
So I think you have to account for that 5
Is there just the range formula that would work though? I mean, y'all still didn't bring it today. I should have brought my thing.
all of them, all the formulas for this section requires a
0. Oh, V naught, and also like the position to be 0 probably.
Yeah.
Mm.
You can rearrange to get V on if you have T. We don't.
All right, that's fine. Let's do it because this is definitely a possibility. We got 5 in the air, and we're wanting the initial velocity, but we have the angle and everything else. So I'm going to go back to y, 5, and then I have v naught sine of 40 t minus 16 t squared, and I want to set it equal to 0 again to find out where this is. And then my x's 0 v naught cosine 40 t, and I need to set that equal to like, oh, I already have that one, don't I? That's that 70 and 4 inches, 72. So how would I express 4 inches? 4 over 12. I know you're you're wanting to put it right next to each other, right? Aren't you wanting to do this?
Yes, actually. So that's how you typically would do it. In, like,
Is it?
and stuff like that.
Is it? I don't. Oh, I don't cook, so I don't know. Yeah, yeah, I'm not gonna. Yeah. Oh, okay. So yeah, this is feet now, right? 4 out of 12. This is now feet. So it's like a little bit more feet, right? Yeah, I'm just being super picky, I guess you can say. Isn't that a third? So I could just do this instead. Feet, and everything should be feet because we're talking feet for my gravity. Yeah. So let's solve for t, I think, and that way we can solve for v naught quicker. So I'm going to divide this to the other side. So t equals this distance all over v naught cosine. And then I'm going to take that and plug it in right there. I need more room though, so I'm going to scroll up. Okay. I can hang. All good. No rush. I was thinking about the 3-hour exam time limit, thinking, man, that's probably too long. But I mean, what is it? What is it though? You know, you have 3 hours, you have 2 hours. What's the difference? You know, if you know it, you know it. You don't, you don't. So, like, why would we get all picky about 2 hours versus 3 hours? I mean, it just, some people write slower. Some people think this way. Some people want to actually do the math and not cheat. You know what I mean? There you go. Exactly. So, like, why are we so picky about time limits like that? Does your boss give you a 2 hour time limit on a project? I mean, well, okay, mine does, but regardless, no, I'm just playing, just playing, just playing. No. Do you know my boss? She, my boss is great, of course. I know, I know. I'm just joking around, of course. I actually self-impose those limits on myself. She says, "Hey, can you give me this?" And I'm like, give me like a couple hours," and I get it back in 30 minutes. And she's like, "Oh, that's cool." But that's just because I want to look cool. Oh, right here. Look, we got to plug in T over there. Mm. I wonder if this is going to be too much without a calculator. I mean, like a serious calculator. You know what I mean?
Well, the one nice thing is you do have one of the VNUTs cancel out on one of the sensors, like with the
Oh, well, then it's easy. Yeah. Okay. No problem. And so this is supposed to be equal to 0 because, again, we were talking about that at the end, right? At the end of it. And so my y value is equal to 0. Let me try to clean this thing up, right? Because it's all junk. So we got 72, 333, and we got sine over cosine. So I'm just going to put a tangent to make it a little bit cleaner. And then we have the 5. Forgot about the 5 in the front. And then this silliness just won't go away. So V naught squared cosine squared. Yes. And this whole thing's supposed to equal 0. Okay, cool. Yeah, this is going to be way easier. I got to use a calculator, of course. Let's figure this thing out. And so this is still in degrees, so that's nice. Here we go. Let's combine those numerics in the front. So all of this turned into 65. I'm going to take, hold on, I really like using different colors here. I'm going to take all of these as a single number in the front. I know it looks a little funny over there, but y'all know Desmos. It'll be okay. Degree mode. I guess I'm expecting it to be huge. I mean, it is 72 squared, so okay. I didn't plug anything in wrong, right? Correct? Okay. I'm getting nervous. I don't like that color right now. Yes. 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 I was about to multiply it. Thank you. That would have been a whole different thing. Yes. Move this over, and then I think I'm going to multiply divide thing, like switch the sides. So V naught squared should be equal to this massive number, which is now positive, divided by this dude over here. And then we're going to square root that answer here in a second. 2, 6, 5. Okay. Yeah, that's not too bad. Because when I square root this thing, that's supposed to be an 899. It should be a little bit better. Okay. That's very similar to the last problem. It was around 40 somethings, I think. Again, this is feet per second. So 46.6. Do not round, then round. All right. Okay. I want to hit submit. Real quick, let me see what the next one is. Okay, I want to hit submit, and then the rest of them we could just do like we did last time, I guess. You cool with that? It doesn't sound good to me, but I'm gonna do it. Kind of scared. Okay, so we skipped around. So let's go check out what I got wrong, or if I didn't fill it in. Yeah, I didn't fill it in. We didn't do anything there. One. Yeah, yeah. I was just talking about it. I think. Okay, that one. Yeah. Oh, but this one, these I got right, so that's cool. Okay, cool, cool. We're good. We're doing good. Of course, this huge red bar at the top again. Okay, cool. Ready? Good. Good. Yeah. Any questions on that? The other ones? Okay. Yeah. I'm finding the formulas are not as great. I mean, but if you could use them, I mean, they make it way better. Mm. But what if? Okay. Really? I don't know about that. Faster than Professor Rabani? Is that what you just said? Oh. That's funny. Formulas. Right? Aren't they always formulas? Oh. Oh my. Rigorous. It's rigorous. That's the nice word for it. That's good point. That's a good point. So cap T, cap N, cap B? No cap B's. Yeah, no cap B's. But cap T, cap N, of course. Find my first derivative, divide by its magnitude, and that's pretty much it, right? Yes? Oop, not that way. Hold on. This way. So yeah, let's start finding derivatives. You're going to help me here. So this cosine goes to A, and sine goes to, and that square root goes to A. I was trying to trick him. Yes. The T goes away. So magnitude, if you note here, we have 1, essentially, right? So it's like 7 squared plus 7 squared. No, because you have to factor it. It's just 7 squared times 1. Like, because it's cosine squared plus sine squared. Blah, blah, blah. That goes away. It doesn't matter. And then plus plane 7. Exactly. So 49 plus 7. Cool. That is not what they got. So, what? Well, we got the 7 in the top. Let's see if we can get to what they got. Oops. 56. So, 56. Does it have a 2? Leave behind. Okay. Does that have a 2? 14? 2 and 7? So then I think this is my pair that they're pulling out. I'm just making sure that I can get to what they got. You know what I mean? So 2 and then a 14. And then if you pop it in the top and leave the number behind, then the 7s there will cancel. And yeah, then you'd have a 2 and a 2 make a 4. So yeah, that's how they're getting their junk stuff, their stuff. So we need not do all that, right? We got this guy, so you take this one divided by this thing, and you're done. Like, I just want to erase what I just did, but regardless, this thing divided by that thing. Yay. So the length of the curve isn't that like an integral or something? And they say it. Yeah. Square root of the squares. Um, and it's with my derivative one, right? S- No, this is the magnitude. Yeah. Right. Yeah, the magnitude. You're integrating the magnitude, which is the square root of the squares and all that stuff. Yeah. Not cosine though, it's sine. My bad. I'm gonna just make it look pretty for a second here, so that I know I'm not gonna mess up, because I'm prone to messing up. Oh, okay. Well, you're right, because it is a T. You're right. Okay. You're right. I'm still very nervous about that because a lot of times, we actually get letters and stuff. You're right. Okay, you're right. Good. 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 Yes. Yeah, I know. I'm just nervous. I get nervous. Okay. There's a lot of moving parts. But you're right. You're right. You're right. Yeah. Yeah. Because the cosine and sines cancel. Yep. Well, that made it easier. Cool. It's not too bad. Same thing, but now this one's not going to cancel. You want me to do it? Yes or no? Sweet. Let's do it. I love doing it. Now notice there's an I and a K, but I mean there's no J anyways, so like it won't matter. I might just put it there just because though, because I'm still nervous about it. So 2, 0, of course. When I move the 3 halves down, it cancels with the 2/3, but it leaves a what power? 1/2. Very good. Yeah, 1/2. Magnitude 4 plus t, actually, because you're squaring it already. Square root of the square cancels there. Awesome. And so then I'm going to do this for my answer. So you can see 2 over that, square root t over that. But then I'm going to do integral 0 to 21 of the square root of 4 plus t dt, because that is the bottom that we're doing. So 1/2, we're going to have 3 halves, so 2/3, 4 plus t, 3 halves from 0 to 21. When I plug in a 21, we get 25. Square root of 25 is 5, or to the third power is 125. And if I plug in a 0, I get 2. 2 cubed is 8. And, well, there's my answer. I should probably just solve it since they have a nice clean number here. 1, 1, 7? No. Yeah? If you say so. Oh, okay. You're playing the prime, not prime game, basically. Is that prime? No. Okay. Cool. Good. Okay. Yeah. Take the magnitude, integrate it. I guess that's kind of like why it's all kind of one problem, I guess. This is on your exam. 100% sure. Cubed? You want me to do it? Yes or no?
Actually, yes.
Okay, actually, then I will do it. I like doing this. It'll be 6 times 3.
6 times 3.
Cosine squared and then times. Well, times just sine. Yeah, but you got it. And it's a negative sign, so I put a negative in the front. 18 sine squared. Derivative sine is a cosine. Aww. Did you see what I did wrong? Are you laughing at me? Yeah, you know it. Ah. Okay, is that better? Thank you. But look, they don't have an I here either. Yeah, guess not. Magnitude R prime. So then the 18s I can factor out. That's about the only good thing that's going on here. And it won't matter about negative or positive, but I got cosine squared t sine of t, and all of this is squared, plus sine squared t cosine t squared. There we go. Okay. 4 power, 2 power, 4 power, 2 power. I guess I can make the 18 come out. That okay. That is actually a legit thing. There it is. And yes. So I'm not discrediting what you're saying, but I'm gonna keep going. Sure. Oh yeah, yeah. Because we factor that out, then this goes to 1, and then these get the square root applied to it, right? T. Perfect. Very good. Good application there. So this is my magnitude, and so what I'm going to do is take this divided by that. So basically, a cosine and a sine will be removed from each one of these, leaving only one cosine behind and leaving a sine behind there. But now I have to integrate this thing. Oh, yes. Yes. Let's do that. Very good. So, there's a couple ways we can do this. Who wants to do trig identities? I'm just joking. There's one, I mean, really, I don't remember hardly any, but I do remember sine of 2t is 2 sine of t cosine of t. That's one of those that I remember. You don't remember that? Yeah, I'll use some, I guess. But like whenever I see sine and cosine multiply together, I think this guy. And so basically you would just do this, and integrating this is like a tiny u sub. Tiny, because it's only like 2t instead of like what here will be a cosine or something. But yeah, let's do the regular u sub. You're right. There's no tricks here during the exam, Chad. We're just gonna do math. So which one should be your u? No, let's do it. So cosine derivative of cosine is a negative sine. And so then if you remember how I do it, I go one extra step. so that I can say that I have u times sine of t, and then I have du over negative sine of t. And then those guys cancel. Oh, too much. The negative will come out to the front. I should definitely do this to remind myself. When we start integrating a whole lot more in this class, I'll be a little bit more picky, I suppose. So u squared over 2, basically, from t equals 0 to t equals pi over 3. So that's going to be a negative 9. We already got u was a cosine, and now I really just have wanted to go use that formula. But that's fine. No trig identities, Chad. Yes. Oh, yes. I'm just not true. I don't personally, but that is what is recommended by everyone else. So yeah, that is right. That's just the Chad thing. That's just the Chad thing. Yeah. I mean, everyone's got their own style. I also go one step further. A lot of people stop right here, and I mean, here it's not too bad, but they expect you to always know, and I just don't like that. I like to plug it in, but that's just me. Everybody's got their own format, their own flavor. So this is 60 degrees. So cosine at 60 is 1/2. Yeah, 1/2. You're good. And then I'm minusing whenever I plug in 0 is just going to be a 1. I know that's kind of weird because it's already a negative. So I'm minusing a negative would make, the positive over there. So then I got basically 9 minus 9 over 4, right? So I don't want to do math calculator. And cool, there it is. Sweet. Yeah, that one took a little bit of time. I personally, I think that the trig identity would have been faster, but you have to know it. You have to remember it, and if you don't remember, even put a 2 in the wrong place, the whole thing's wrong, right? So it's up to you. This way is definitely tried and true. And you have 3 hours, so you're fine. Cool. Is that good? Good to go? Cool. Okay. What else do we got here? Same thing. We already did one of those. So that's the arc length is just the arc length, not cap T. Same thing. We had a 3/2, 2/3. And it even doesn't have the J. It's the same question. All right. Here we go. This one's do you want me to do this one? Yes? No? You're okay? You're okay? I can try to find another one. This guy? Oh my gosh. No, we're good. You're good. It was just like I was preparing for you to say something, but then it. Okay. Yeah. Because that one confused me yesterday. You're doing it for my sake. Yeah. You want Chad to learn. I mean, I have learned a lot. It's true. Now, I don't know if it's all good learning, but I did learn a lot. Well, that's true. This is only a 2-dimensional vector, which is at least a little bit nice. Taking the derivative of this guy, we can always take a derivative. Derivative ln, 1 over stuff. And then, yeah, derivative secant is secant tangent. Very good. Do y'all know the little trick where every one of those derivatives has 2 secants and a tangent? So if you have a tangent, you get two secants. If you have a secant, get a secant tangent. Did you know that? You already knew that. All right, cool. Oh, okay. Yeah, that's just one of my reminder tricks. That way, I always remember this one. But because of the way it is, I think they just cancel there. So I mean, that's cool. And now we have just proven that the integral of tangents is ln secant. So there you go. That was yesterday's hang up, by the way. So we need magnitude of r prime. The 3 is going to come out. I don't want to just do that. I mean, I do, but I just want to be careful. I want to be careful. Yes, the 3 will come out. Tangent squared plus 1. But I think there's a formula for that. Isn't that like secant squared? Straight up? Sweet. So then cap t would be this dude here. So 3 tangent t3 all divided by 3 secant t. So all the 3's cancel. And I'm going to go sine and cosine on you guys. So we got a sine over the cosine, big division, 1 over cosine. And then this guy, the 3's cancel, so it's just 1 over cosine. No, it's 1 over cosine. Ugh. Exactly. So yeah, these cosines cancel. So then yeah, we got a sine, and then this guy pops it in the top. Cosine with 1. So that's confirmed. We got what they got. So that's nice. Step 1. Now to step 2. Which should be easier now that we have this, right? So cap t prime, my derivative of sine, cosine, derivative of cosine, negative sine, and then the magnitude of this guy, we already know it. What's the magnitude? 1. So then, well, there's your answer for that one. Cool. And then the curvature, there's a few formulas for this. Would you want me to do the VA ones? V cross A, something or other? No? Which ones? So that would be the magnitude of cap t prime divided by the magnitude of r prime. Thank you. Good call, because that's a 1. And this guy here was 3 secant. And so because that's in the denominator, we can pop it up as a cosine in the numerator, but the 3 gets left behind because the 3 was still in the denominator. Oh, there we go. Yes. It does take a while. And yeah, because you're needing to try to factor, but then it doesn't look pretty. Yeah. I do too. Is that good? Good? You were just texting? That was it?
No, I was checking because my phone was going off. I'm like, what is this on that? Yeah.
I'm just playing. I don't care. Yeah, it's not a big deal. Okay. Yeah. You gotta say something. That one's too easy. We just did this one essentially.
Yeah, that section on the bottom did the same
Yeah.
exact problem. It had different numbers, but it was a lot of the same problem. Well, some of them, sometimes you had it where it didn't cancel like that. Some of them you had it where you didn't have a sine and cosine, so it didn't cancel.
That's what I'm trying to look for.
Oh yeah, the ones with the polynomial questions instead of having the sine cosine.
Yeah, all these are having sine and cosine. Right? This one is different, is a different question though. Okay. Do you want me to do this one? No? Y'all don't care. Okay.
I think we already did that one earlier.
Yeah. Okay, we're good then.
Or one like it, I should
I know,
say.
so you're wondering, is the square root ones on there? Well, this is the practice quiz. It should be the bigger pool, right? So it comes down from it. So I can go check it after class without the recording. But if it's not here, then it shouldn't be there because that's how it's designed. You're still looking at me odd. You're like, but not in linear, and I know that's a different class. It's a different class. So on this one, just put zeros. Keep moving. No. Yeah. Well, actually, if you think about it, you're wanting to take a derivative and you start getting numbers, right? So,
Given that this one part A need derivative and then the second derivative.
is all zeros. So whenever you dot or cross it, it doesn't matter.
Yeah.
Yeah.
If you see that, then it works out. But if you see that, it would be still a number when you take the second or
You want me? Are y'all okay with me doing this one?
yeah, sure.
So first I need a formula for this stuff, right? So a sub t is
That's the dot product one, I believe.
so say it a dot v dot a. Yep. Cool. And then a sub n. Like this guy here. Perfect. Perfect. Yes, I like that. And because they're polynomials, finding v and a are pretty easy here, regardless, even if it's, sometimes a little weird. So let me write this thing up. And then derivative again. And so if I dot these, 4t, I guess. And when I cross these, which I make it look easy, but it's going to be a lot of little work here, we have nothing, nothing, -6. So here, you know what I'm going to do? I'm just going to do this. I'm going to do it properly. So it's a -6 negative j, I think. 0, 0. And then that's a 4 positive I, and then zeros for the last one. And we would get 4, 6, 0. But then I need to find the magnitude of that guy. Like, those are just numbers? There's no letters? You're right. You're right. That's cool. I should probably be able to figure this one out. Is it 40, 52, 52?
52.
Okay. All right. And then I need the magnitude of v.
Oh, but with this one, don't we want to plug in the t since t equals 3?
There it is. I'm gonna go a tiny bit further, just so that I'm kind of like fully ready for it. So this would be my like raw one, but then like you said, t equals 3 for us.
V cross A is 4, 6, 0.
Yes. Yes, that was my cross product. Yes. Yeah, 13, 9, 4, 36, 40, 49, which is 7. It's probably where they got those 7s over there. Cool. So then, yeah, we just kind of mush them all together then. So my AT would be 4 times 3 all over 7, because again, I have to plug in that 3. And AN Sorry. I don't know why I'm turning things on my neck. So square root 52 over the 7, which if you kind of look at this and that, it's very close. 52 would have a 2 for sure, and then we had 26, and then the 26 has a 2, so that's why you pull a 2 out and whatever. And 13. That's right, that makes sense. Thanks for that. You're mentally 13ing me. Cool. Yeah? Yeah. Okay. Sweet. Not too bad. Oh my gosh, it's the same thing, right? Oh, at 1. And so I would recommend, I think I overdid it in this problem. I would say right here, start plugging in the t equals 3, t equals 3, t equals 3. And I think I didn't do that because I got like a number here, and I got like numbers here, and I was just forgetting to. But like, don't do t's all the way down, right? Just numbers, and it'll be way easy. Last one, same thing, 0. So I mean, I know it looks crazy, but we've done the derivative of this stuff, right? Just and then you plug it in immediately, kind of thing. Would you want me to do it though? I can do it. Yes? Okay. Since this is the last one. So that's not gonna be good later. So product rule, right? The 6 is gonna be in the front. That's easy. I'm gonna leave the this one alone, and then the cosine. 6 is in the front. Leave that one alone, and then my cosine turns into a negative sign. Whatever order you choose, that's up to you. Similar here, but then the sine will go to a cosine, and that's a square root 7. Go ahead. Is it the vertical thing I'm doing? Sorry. It throws everyone off, I know. Sorry. I'm just trying to organize it for once in my life. Yes, I know, right? Chad, you never organize anything. And I want to plug in a 0, but we have to take the second derivative, and then we can start doing that. So I'm going to just duplicate this, because that's the same as what we just had. Essentially, I can just duplicate that one without any kind of issue. But now this next one here, I've got to do more math with. So I'm going to leave that one alone. Derivative of negative sine turns into a negative cosine. And I know things are going to cancel. We'll just see as we go. Again, because this was the same as the original, I'm just going to duplicate this down here without any math changes, I guess. But then I actually have to take the derivative of this guy. So cosine will go to a negative sign. And then this guy is the same. Yeah. Notice that I'm putting my square root 7 in the front. I know that it's not super conventional, but it reminds me it's a number. It's a number. Yeah, that's why we're going to plug in 0. But I mean, I think we can cancel stuff immediately. Like we got a positive and negative cosine, negative sine, positive sine, and we're going to plug in t equals 0 anyways. because one of them's going to go away, right? Because the signs are going to go to 0. So then it would be a 1, so it would just be a 6, and then this goofiness there. And then the signs are going to go to 0. So, like, I guess the first one's 0. Here is the 12, because there's 6 plus 6. We get 12, and then we got that silliness still there. V dot A, anything times 0, 0. 6 times 12 is 72. And then this times this, you'll get 36 times 7, because the square roots cancel essentially. Calculator. Get that out of the way here. Okay. When I take the cross product, though, right? No, go away. Okay. When I take the cross product, this will be interesting. Let me just rewrite this, what we got here. Yeah. Oh. What other formula is there? Right. Is it like this one, or is it like this AT thing that we're gonna find exactly? Let's look that up. You're right. Because if there's an easy formula, I'd rather do that. Okay, that was too far. It's like the last section here. No. It's 13.4. This stuff. This one. So I could yeah, I already have that. Well, okay, I could find that. That's not too bad. And then this one I'm going to find along the way anyways. So yeah, let's find AT, and if it's pretty, then I'll do that one. Yes. You're right. And see, that's why sometimes that formula is great. Sometimes it's like, yeah, I don't want to use it, right? It kind of depends on the... Right. So let's find magnitude of V first. And that would be the stuff here. So we got 6 squared, and then the 6 square root of 7 all squared. So they all have a 6 that I can pull out, but then that means I got a 1, and then basically a 7. And the square root of 9 is 3. 3 times 6 is 18. So 324 over 18. Is that just 18 again? Yeah, I don't know math. Where's my calculator? I thought I had a... Oh, he's up right here. Yeah, look at that. So then, if I take that with my formula here, let's pull up that other formula. We have this number. The magnitude of A is just going to be whatever this magnitude is, which is definitely nicer than doing any of this. So let's try that out. I actually have never used this formula ever. So this will be fun. The magnitude of this guy would be square root of the squares. So I got a 12 squared, and I got 36 times 7, essentially. But then all of this I'm going to square, right? Okay. Yeah, that's strange. Let's see it. So square root of the squares cancel. So I got a 144. I got I got calculator. 36 times 7. Okay. And then I got 18 squared. We know is 324 now. Oh, thank you. That would definitely change everything. Thank you. 252 minus. Okay, there we go. Thank you. Yes, that would have thrown my answer off a lot. And that's why we write everything down. Square root 72, like just straight up. What did they have? So if you pull out a, they're saying pull out a 36. 36 times 2 is 72. All right, there we go. Whew, yeah, that worked. That was actually way better. Thank you. Very good. So yeah, it's a good thing we have all those written down on our note cards, huh? I know, right? Yeah, that one turned out really good for this one. Cool. Yeah, it is kind of weird. Yeah, it's square root and the square, they like automatically cancel before anything. Yeah, very strange. Cool. I can't hit submit anymore. We're done. So we're done with that. And we're done for the day. Actually, that was it. We had too much fun. We're done. So, any last minute questions? Anything? If y'all have questions tomorrow, bring them to me. We can do those first. Otherwise, we keep going. Yeah. Oh yeah, yeah, yeah. We can do that. Yeah. Remind me. Yeah, that's definitely possible. So yeah, you bring me the test question stuff first. We can do that first tomorrow if you want to. And if you have nothing left, that's fine. We jump back into that stuff. Thank you guys.